Interesting property of the Cobb-Douglas production function is that any firm that uses a Cobb-Douglas production function will have an expansion path which is strictly linear, and this can be expressed by the equation beta times WL minus alpha times RK is equal to 0. This is when your Cobb-Douglas production function is expressed as Q is equal to A L to the power alpha and K to the power beta. Observe the formation of the equation. W times L is the total labor cost. It's being multiplied by the exponent of capital. And R times K, which is the total capital costs, is being multiplied by the exponent of labor. Now, in order to understand this, understand as well as prove this property, I will first discuss the concept of an expansion path. Now, we know that given a target level of output, such as IQ naught, where you have labor on the x-axis and units of capital on the y-axis, to produce this target level of output represented by isoquant IQ naught, a rational producer will always want to do so at the minimum possible cost. So, the equilibrium point, when he wants to minimize his costs to achieve this target level of output, will be represented by the point of tangency between the isocost curve and the isoquant curve. Here I've shown IC naught as the lowest isocost that just touches the isoquant curve. Now, say the plant wants to expand its output and produce a higher level of output as represented by IQ1. If we assume that the wage rate and the cost of capital remains the same, the least cost combination for producing IQ1 will be represented by equilibrium point E1, where IC1 is the lowest possible isocost curve that just touches isoquant IQ1. Now, the line that passes through or traces the equilibrium points is what is called the expansion path of the firm. So it basically traces out the least cost combination points of producing different levels of output as the firm expands in its scale and size. Now, as you can see, at each point on the expansion path, there is an equilibrium which is characterized by the equilibrium condition of least cost combination, which is that the slope of the isoquant is equal to the slope of the isocost curve, which is represented by the ratio of the cost of labor to cost of capital, W by R. I can also write this as MPL by MPK is equal to W by R. Now we know that this equilibrium condition will be satisfied at every point on the expansion path, as the expansion path traces through all possible least cost combinations of output. So we start the derivation of the expansion path equation from this equilibrium condition. This is the first order equilibrium condition of finding the least cost combination for producing any given level of output. Instead of MPL, I can write alpha Q by L. Similarly, instead of MPK, I can write beta Q by K is equal to W by R. Now I can cross multiply and I can cancel out the Q so that I get alpha by beta K by L is equal to W by R. Now, by cross multiplying, I will get it as alpha times R times K is equal to beta times W times L. Now, taking alpha R K to the right hand side, I can express this as beta times WL minus alpha times RK is equal to 0. And thus, we have derived the equation for the expansion path of a firm that produces as per the Cobb-Douglas production function.